and welcome to the ROCCO Innovators 2026 Cellusys presentation from the team Weird Science. Let me briefly introduce myself. I am Charles Bernard, a 20-year experienced network engineer. I worked in roaming, IPX, A2P, IoT, in operations, engineering, product management within operators and vendors. I am now in charge of product at Cellusys. During the next 15 minutes, I will introduce you to Anna, our agentic network assistant, designed to improve operations and make network knowledge more accessible. What is the point of knowing you are sick if you don't take any medications? What is the point of having a smoke detector if you don't have any fire extinguisher? Well, it is the same for monitoring and alerting. Detecting an error is only valuable if you can investigate and resolve the issue. Mobile networks accumulated systems and technologies. They're not only hard to maintain, they're even harder to understand or troubleshoot, even with the best available tools. Telecom is not attractive anymore. It is not easy to hire new talents, especially in a cost reduction environment. This results in complex systems and too many of them, but too few skilled resources to operate them. Yet, customer expectations are getting higher and higher. Internet on their devices shall work at any time, anywhere. Operators cannot afford the level of excellence from their support teams to decrease over time. Lack of knowledge leads to inefficiency, longer or wrong resolution, and eventually to a bad customer experience. So, how can operators ensure diagnostics and resolutions are consistent over time? How can the support teams be more efficient but with less resources? Can network knowledge be more accessible while networks themselves are being more complex? There is a challenge for operators to keep excellency in their support teams, from customer services to advanced support. A challenge to ensure proper investigation and resolution, especially in network combining 30 years old and recent technologies with newer ones coming. In this marketplace, there are several solutions. Most operators will offload the support to a business process outsourcing company. But that is just passing the hot potato onto someone else, and it does not solve the learning curve of new technologies or new network elements. There are also automation tools, scripts, but they are not flexible. They are tailored for predetermined cases and quite complex to maintain over the years. As much as training programs exist, it is always a matter of time before the knowledge is diluted. Operators need a solution that guarantees the quality of investigation, diagnostic, and resolution. They need a reliable, fast assistant, consistent, and capable of improving over time. And this is what is Anna, an agentic network assistant, meant to be used by operators' employees. Anna takes as an input what would usually be the starting point of troubleshooting, the description of an issue and its related IMSI. It will point out what is the error and a suggestion for resolution. Considering that investigating and resolving are complex tasks, it can also be used for simpler requests. For example, informing on the status of a SIM card or even get statistics of the network and its subscriber base. Anna is an agentic AI, not another LLM. It is capable of autonomously take actions, use external tools, plan, and learn. How does this Anna concept work? Anna is like an orchestration aware of the documentation of the network and a methodology for troubleshooting. It also knows what tools to use. These can be internal APIs, databases, logs, or traces. User can interact with Anna via a regular chat interface. The user inputs a request, typically the description of an issue. The issue description is sent to a LLM along with the context. Based on the context, the LLM analyzes and responds what to do. What are the next steps? The tools are then queried based on what the LLM requested. The tools then respond to the queries, and that response is forwarded to the LLM. The LLM then analyzes the response and with the context is capable of pointing out an error and a resolution. The analysis is forwarded to the user. So, user has submitted an issue and received a diagnostic and a suggestion for resolution. ANA is also capable of receiving feedback if a response is correct or if a user wants to add new relevant information. ANA acts as a support team member, capable of assisting support teams while troubleshooting. With the same input, each diagnostic will be accurate. The suggested solutions are independent from who is interacting with ANA. It also allows faster diagnostics via automated tools, reducing the risk of human errors. It can be accessed by a large number of employees at the same time or even integrated into a larger full process. ANA is not a black box. It is actually capable of explaining its reasoning and the details of the interactions with the different tools. This key aspect allows it to be used to help new joiners and learn from it. Furthermore, the assistant can be configured for generic network or subscriber usage, enabling a larger variety of use cases across the mobile operator workforce. This solution offers a response for a need of constant, fast troubleshooting and better access to network information. The benefits are straightforward. Troubleshooting is made easier and is more reliable. Network information is made more accessible across the company. More tickets can be handled by the same amount of people, improving operations while decreasing troubleshooting times. Easier access to network information also improves business processes and decreases internal friction. ANA's capability to explain its reasoning makes it a learning system as well, improving global knowledge within the operator. Usage cost is mostly conditioned by the use of a LLM. Other components of the solution can be self-hosted on regular servers. LLM cost of an interaction with ANA is estimated to an average of 5 cents. In comparison, a human will take 10 minutes to 1 hour to perform the same work. However, the biggest challenge is the setup. Like any AI solutions, it requires very good input data, accurate documentation, and clear guidelines. The scalability in terms of users is not a problem, as many of them can interact with ANA at the same time. Scalability for a larger network with more tools and more use cases could be a challenge, though this can be achieved by defining domain-specific context. Each context passed to the LLM will depend on the type of request. Our team is a duo. Raes Kubaisi, a senior software engineer who has been developing software solutions for mobile networks for the last 10 years, and became an AI specialist over the last years. Charles Bernard, myself. I acted as the user, guiding what the solution should do. I also wrote the documentation and troubleshooting guidelines. This is a duo of competence. The first member has been capable of understanding the requirements and made sure to have the right approach in technologies to come up with the appropriate solution. His knowledge in prompting, passing an accurate context, allowed the LLM to be as efficient as possible. The second member has more than 10 years experience in troubleshooting mobile networks. The conjunction of troubleshooting expertise and network knowledge greatly helped to have a good set of documents to start with. At the end, ANA is in fact a direct need of one of the team members, validating the relevance and usefulness of such solution. What is the technology powering ANA? ANA is mainly a Python program orchestrating the interaction between the user, the LLM, and the different tools. It uses several Python packages, respectively Chainlit, LightLLM, and FastMCP. MCP is a protocol specifically designed for LLM interacting with external tools. MCP servers act as a mediation between the LLM natural language answers and the strict interface requirement of the tools. The assistant also uses Langfuse and ClickHouse for logging and tracing. It logs all user requests, interactions with the LLM and the tools. This part is critical to understand the reasoning of ANA. This is a generic setup for Agentic AI. The value of this AI is in its use case, a super agent for mobile network, a network assistant. This setup also allows for more use cases, either with different prompts or even dedicated new Agentic AI. For the proof of concept, we deployed ANA in Zayat, an IoT MVNO, sister company of Cellusys. The aim is to help the NOC manage customer requests or incidents, which is 95% of the received tickets. The advantage of using Zayat is that it has an accurate documentation and a clear set of guidelines on how to troubleshoot. We also have access to all the tools we need: Portal API, pcap traces, network logs, and so on. ANA is configured to act as a super support team member, capable of handling all tickets, thus assisting the NOC team. It is set to improve diagnostics and provide clear guidelines on what are the next steps. Here is a partial screenshot of a discussion with ANA. We can see the prompt. The input is relatively vague but contains a SIM identifier. You can see all the steps the Agentic AI is taking. In green, the reasoning LLM. In red, the queries to the tools. And here's the response from ANA. You can see in the analysis that ANA detected that the SIM is suspended in the HLR. As next steps, it is suggesting to reactivate the SIM in the HLR. So, we solved the HLR status, but the customer is still complaining that data is not working. ANA knows that we are talking about the same subscriber. There is no need to remind its identifier in the prompt. It is suspecting a missing data session, and this suspicion is confirmed by the fact that there are no corresponding data sessions at the packet gateway. In the resolution, the Agentic AI suggests to verify the APN settings at customer end. Now, the customer has changed the APN on its device. ANA is confirming the issue is resolved. ANA is providing its findings. It checked the active data session with a successful exchange of data and an assigned IP. It even knows which mobile operator customer device is currently attached to. As we explained earlier, ANA is also capable of answering more generic questions about statistics or usage. In this example, the request is about the number of connected subscribers in Italy. And here is the response. Also, let's see in details this interaction with the database. If we expand it, we can see the exact SQL query sent to the database to know the answer to the question. This demonstrates that we can understand ANA's interaction with the tools. Last key feature about ANA, its capability to get feedback and learn from it. In this example, ANA believed MNC006.MNC238.GPRS is a malformed APN suffix. So we inform it's not, as it happens on 4G networks. The Agentic AI understands and suggests a proposed knowledge update in order to correct its reasoning and the list of tools it will affect. The user can then approve or not the correction. This demonstrates that ANA can easily learn and be improved while being used. The evolution of ANA unfolds in several stages. We will optimize ANA for other use cases, such as generic information, statistics, and usage related to the network. It is doable for now, but the current prompt is not optimized for it. We will work on the security aspect of jailbreaking. Jailbreaking is a known risk of LLM, where a user will intend to bypass the safety guardrails when interacting with the system. We will test ANA and investigate how to prevent jailbreaking. Lastly, we will introduce a confidence scoring concept, where ANA will inform how confident it is, essentially preventing hallucination. More use case, improved security, and more confidence will directly increase the adoptability of the solution, improve operations, and set ANA for another round of improvement. Those improvements would be: integrate ANA with the monitoring system, removing any human intervention between observability and actionability. Improve the context of the Agentic AI to shift from a single customer complaint scenario to complex investigation of quality loss or drop of usage scenarios, typically notified by a monitoring system. The last improvement will be that ANA will not only suggest a resolution, but will also execute it. The tools will not be read-only access, but will be capable of modifying network elements configuration and subscription settings. This last improvement is probably the most ambitious one, but we believe that the combination of those improvements is the path to scaling networks. So, what's next? We see capabilities of Agentic AI as more than just ANA. We see it as a shift in interactions with APIs and networks. We will consider using a similar approach to the Cellusys portfolio. We will also consider network APIs, such as GSM Open Gateway or Network as a Service APIs, to be integrated into such agentic AI. The main driver for HANA was to improve operations for Zayot, but we were convinced that it actually brings value beyond network operations, and there would be an interest from mobile operators. There are still challenges to overcome around security, using external LLM, and integration with operator tools and documentation. But we believe in HANA's value, and we are convinced operators will be on board to integrate and use it. We also hope you believe in the value of HANA for operators.